Have you ever wondered if there could be a universe within our atoms? This might sound like a line straight out of a science fiction novel, but it's actually the fascinating reality of quantum physics. Quantum physics is the study of the tiniest particles in the universe, those that make up everything we know and see. It's a field that's absolutely vital in our understanding of the universe, yet it's also one of the most mysterious and complex areas of science. Now, let's delve a bit deeper. In the quantum realm, particles don't behave the way we expect them to. In fact, they don't behave like anything we're used to in our everyday macroscopic world. You see, particles in the quantum world have a dual nature. They can behave both as particles and as waves. This is known as wave-particle duality, and it's one of the fundamental concepts of quantum physics. Imagine, if you will, throwing a tennis ball at a wall. In our world, it would bounce back, right? But in the quantum world, the tennis ball could also behave like a wave and pass right through the wall, or even be on both sides of the wall at the same time. Sounds mind-boggling, doesn't it? But that's the quantum world for you. This dual nature of particles is just one of the many peculiarities that make the quantum realm so fascinating. And it's not just a theoretical concept. It has been proven time and time again through various experiments, such as the famous double-slit experiment. The results of these experiments have led to technological advancements that we use in our daily lives, like lasers and semiconductors. So, next time you're looking up at the stars, remember that there's an entire universe inside every atom, a universe that doesn't play by the same rules as ours. In the quantum realm, the traditional laws of physics simply do not apply. Imagine being in two places at the same time. Impossible, right? Not in the quantum world. Welcome to the curious realm of quantum superposition. This phenomenon, as mind-boggling as it may seem, is a fundamental concept in quantum physics. It's the idea that a particle can exist in multiple states simultaneously. Yes, you heard it right. Simultaneously. Picture a coin spinning in the air. While it's spinning, it's neither heads nor tails, but a bit of both. Only when it lands, it becomes one or the other. Similarly, a quantum particle exists in all possible states at once. It only settles into a definite state when we measure it, when we observe it. Now, let's take a detour into one of the most intriguing thought experiments in physics, Schrödinger's cat. Conceived by the Austrian physicist Erwin Schrödinger in the 1930s, this experiment was designed to illustrate the absurdity of quantum superposition when applied to everyday objects. Imagine a cat sealed inside a box with a radioactive atom, a Geiger counter, and a vial of poison. If the atom decays, it triggers the Geiger counter, which then breaks the vial, releasing the poison and killing the cat. However, until we open the box and observe, we won't know if the atom has decayed or not. According to quantum superposition, the cat is both alive and dead at the same time, until observed. Sounds crazy, doesn't it? But that's the quantum world for you. A world where the common sense of our everyday experience is turned upside down. A world where particles can be in two places at once, where they can spin clockwise and counterclockwise at the same time, where they can be both wave and particle simultaneously. So next time you think about your pet cat, remember, in the quantum world, a cat can be both alive and dead at the same time until observed. Imagine two particles, miles apart, yet influencing each other instantaneously. Welcome to the fascinating world of quantum entanglement, a phenomenon that continues to puzzle even the brightest minds in physics. Now, let's dive deeper. Quantum entanglement is a special connection between particles, such that the state of one particle is immediately connected to the state of the other, no matter the distance between them. Change the spin of one particle, and its entangled partner reacts instantaneously. This connection, this bond, transcends space and time. But this concept didn't sit well with everyone, especially not with Albert Einstein. He was uncomfortable with the idea, to say the least. Einstein, a firm believer in the predictability and order of the universe, found this concept to be, in his words, spooky. He called it spooky action at a distance, a phrase that has since become famous in the world of quantum physics. Einstein's discomfort stemmed from the fact that quantum entanglement seemed to defy one of the fundamental principles of his theory of relativity, that nothing can travel faster than the speed of light. If two entangled particles can affect each other instantaneously, wouldn't that mean information is being transmitted faster than light? Despite Einstein's reservations, quantum entanglement has been experimentally confirmed time and time again. It's a reality of the quantum world, a world that often defies our classical understanding of physics. And while it may seem spooky, quantum entanglement holds promise for future technologies like quantum computing and quantum cryptography. So, here we are in a universe where tiny particles can be intimately connected across vast distances, where actions can have instantaneous reactions miles apart. A universe that's beautifully strange and strangely beautiful. A universe that, even today, keeps us questioning, exploring, and marveling at its mysteries. Even Einstein had trouble accepting that quantum entanglement could defy the speed of light. What if you could walk through walls? Quantum particles can. This intriguing phenomenon is known as quantum tunneling. It's like a magic trick, but it's not magic. It's quantum physics, the rule book of the tiny particles that make up our universe. Imagine you're a ball rolling back and forth in a valley. According to classical physics, to escape the valley, you'd need enough energy to climb over the hill. But in the quantum world, things work a bit differently. Here, you don't necessarily need the energy to go over the hill. You can simply tunnel through it. Quantum tunneling is the process where particles move through a barrier that, in the classic sense, they should not be able to. It's as if you suddenly found yourself on the other side of a wall without having to climb over or go around it. This isn't a rare occurrence or a glitch in the matrix. It's happening all the time, everywhere. It's happening inside the sun, where particles tunnel into each other, producing the heat and light that sustains life on Earth. It's happening inside your body, in the complex dance of molecules that keeps you alive. At this point, you might be wondering, why don't we see things tunneling in our everyday life? Well, the answer lies in the size. Quantum tunneling is most noticeable when you're dealing with incredibly tiny particles. As things get larger, the chances of tunneling happening decreases dramatically. So don't try walking through walls just yet. Quantum tunneling is another example of how the quantum world refuses to play by the rules we're used to. It's a world where particles can be in two places at once, where they can affect each other instantly over vast distances, and where they can pass through impenetrable barriers. So, the next time you find yourself facing an obstacle, remember the quantum particles, fearlessly tunneling their way through barriers that seem impossible to overcome. Quantum tunneling defies the classical understanding of boundaries and barriers. And it reminds us that in the quantum world, the impossible becomes possible. You might think quantum physics is far removed from your daily life. Think again. Have you ever wondered what powers the technological marvels we take for granted every day? From the smartphone in your pocket to the computer on your desk, all these gadgets owe their existence to quantum physics. Yes, the principles of quantum physics are embedded in the silicon chips that drive these modern miracles. Let's take a closer look. The transistors at the heart of our computers work on the principles of quantum mechanics. They use the ability of electrons to exist in multiple states at once, a concept we know as superposition, to process vast amounts of information. Without quantum physics, we'd still be in the era of vacuum tubes and bulky computers. And it's not just about the present. The future of technology is also deeply intertwined with quantum physics. Enter quantum computing, a technology that promises to revolutionize our world. Quantum computers leverage the principles of superposition and entanglement to perform complex calculations at speeds unattainable by classical computers. Imagine solving problems in seconds that would take current supercomputers millions of years. That's the power of quantum computing. But it's not all about computers and gadgets. Quantum physics has far-reaching impacts in other areas too, from the development of new materials and medicines to the exploration of the universe. Quantum mechanics is the key that unlocks the door to these advanced fields of study. So, the next time you send a text message or search the web, remember that you're tapping into the power of quantum physics. It's not just about tiny particles in a lab. It's about the technology you use every day, the future of computing, and the expansion of human knowledge. Though elusive and counterintuitive, quantum physics is at the heart of our technological revolution.